Hello everyone, let's see this question. A hot air balloon is released and then it goes up to some 30-meter height, around 30-meter height with almost constant velocity. There is no drift, and after that there is a horizontal drift caused by the wind. Due to that, it follows a curvilinear path. Now here we are observing the balloon using a telescope. Okay, so when we are observing using the telescope, it is being said that it is being observed without changing the azimuth. That means what? The vertical plane in which the telescope is, it remains the same vertical plane throughout. Okay, the telescope is not rotated in the horizontal plane, it is only rotated in the vertical plane. So now if we have to find the ascent velocity of the balloon, so it is given that at 3.35 minute it was at 15 degrees. That means what? That means we can say, since this is uh, happening from a distance of 100 meter, so as this is going up, so when it achieves 15-degree angle, so then what is the height? At that instant, the height that we get would be 100 tan 15-degree, which nearly comes out to be 26.8. Okay, nearly 26.8. Now this height is less than 30. So till here balloon would be rising vertically up. It wouldn't be drifting. So using this we can now calculate velocity of the rise. So velocity of the rise would be what? 26.8 divided by 3.35. So this divided by 3.35 would give us around 8 meter per minute. Okay, approximately this would be the velocity of ascent. Then next, wind velocity at the altitude of the balloon where the angle of elevation acquires its maximum value. So 53 degrees is the maximum value, and you see what is happening. Just try to imagine this. So the balloon as it is rising, so you'll have to, if it is having some drift as well, so as it is rising, it is drifting as well. So wherever it achieves its maximum angle, so the telescope right now is focused like this, okay, and after that the angle has to reduce. Okay, so exactly at the maximum angle point, what should happen is that the velocity should be directly along this line, along the tangent. This should be the direction of velocity. Okay, so that means at 53 degree, when the angle of elevation is 53 degree, which is happening at 50 minute, then velocity, net velocity should also be along 53 degree. It should be along the same direction in which the telescope is. That's why we now don't have to, so if you have a curvilinear path maybe like this, so after this we'll have to shift the telescope down only, right? So exactly at this instant, the line of sight of the telescope would be tangential to this path. Okay, so that means what? The velocity is along the line of the tangent. So velocity is making an angle 53 degree with the horizontal. Vy we already know. Vy is 8 meter per minute. Now Vx we can calculate. So Vy by Vx is tan 53 degree, which is 4 by 3. So Vx is equal to 3 by 4 times Vy. So 3 by 4 times Vy gives us 3 by 4 into 8, which is 6. So it goes up, it has a horizontal velocity of 6 meter per minute. Okay. There is one more question here, that the horizontal drift of the balloon when the angle of elevation acquires its maximum value is closest to. So we'll have to take this figure over here. So this is the situation at 15 degree, okay, and beyond this it continues to rise vertically a little bit, and then after that it goes in a curvilinear path. We don't have to worry about that. We just have to worry about the displacement. So what happens is that finally the angle that is that we are seeing is 53 degree. Okay, this angle is 53 degree, and hence the displacement would be somewhat along this line. Okay, this is not the actual path of the balloon. Actual path may be curvilinear like this, but the displacement is this much. Now it is given to us that this length is 100. We also know that it has been going up for 50 minutes, right? So that's why, since it has been going up for 50 minutes, we know the velocity of ascent, which remains constant. So that velocity of ascent we have calculated earlier. That was how much? 8 meters per minute. So we know this height. We know that this height is how much? This height is 400, because Sy will be velocity into time. So 8 into 50 gives us 400. So let's say this length is x. So what we would get? We would get 400 by x plus 100 is tan 53 degree, right? Tan 53 degree. So which is how much? It is 4 by 3. So what you would get? You would get that x plus 100 is equal to 300. So x is equal to 200. So horizontal drift of the balloon when angle of elevation acquires its maximum value is closest to 200 meters. Okay.